Hello everyone. So in this lecture we are going to learn about three-state bus buffer. So for the data transfer we required a common bus system. In my earlier lecture I explained you that how to create a bus using multiplexers. So we have already learned that. Now today what we are going to learn, that is how we can create a bus using a three-state buffers, right? You can also call as a tri-state buffer, right? So first you need to understand the concept of three-state buffer, or you can say tri-state buffer, yeah, right? So what is that concept that we'll first understand? Tri-state buffer, what we have, this is a graphical representation of tri-state buffer, right? So in this you have input A, that is your normal input, then your control input C, and then your output is Y. Now, this on your control input, right? So, if you give your control input as 0, right? Control input as a 0, point the output is disabled and your entire gate will go into high impedance state. If your control input is 0, that means this gate will not give you any output. It will goes into the high impedance state, right? But if your control input is 1, right, then based on your normal input, it will give you the output, right? So if I need to create a truth table, so this is my input A, then this is my control input C, and this is my output Y, right? So in case of this A is control input is 0, whether my A is 1, then also it will go to high impedance state, right? If it is 0, then also it will go into the high impedance state. But if my control signal is 1, right, then if my A is 1, normal input is 1, it will directly passed as my Y, right? Output will be the same. And if I have A is equal to 0 and my control input is also 1, so here I'm getting it 0, right? So in general life we can say this control input will work like a switch, right? So if this is on, then whatever input you are having, that same output you are getting. But if it is off, 0, then your entire gate will go into the high impedance state, right? And you will not get any of the output, right? So this is about a tri-state buffer, three-state buffer, right? Now, how we can use this tri-state buffer or three-state buffer into creation of a bus, right? So let us have this. So this is my simple block diagram of this. So what I'm using over here, I'm using 2 cross 4 decoder, right? So in this 2 cross 4 decoder, I'm having like 4 outputs, right? Here I'm having the select line S0, S1, right? And then I'm having my enabled, right? Then I'm having like 0, 1, 2, 3, 4. That means from this I can select any one of the line, right? If my S0, S1, this is 0, 0. So what I output I'm getting here, that is 0th line, right? If I'm having the 0, 1, right, at that time the first line is selected. If this is 1, 0, then the second line would be selected, and if this is 1, 1, then the third line would be selected, right? So this is a concept, right? This is like enable should be on, right? It is enabled, right? So in this scenario you are selecting the lines, right? So here I am getting like 0th line is on, 1th line is on, second line is on, third line is on, right? Okay, fine. Now here what I did, this output I am adding as a control signal. This output, the selection line, will work as a control signal over here, right? For all this four tri-state buffer, right? Here also I'm having tri-state buffer A, B, C, D, right? And the one signal I added, that is zeroth line of word A, zeroth line of word B, zeroth line of word C, and zeroth line of word D, right? So if I select this 0, 0, so that means zeroth line is selected, right? So this would be considered as on, right? This would be 1, rest all will become 0, right? So in this scenario, according to our concept of tri-state buffer, this B0, C0, D0, this three circuits will be disabled, right? Only if one circuit is enabled, right, and I'm getting the output, right, whatever input I'm having, that input output I'm getting. So at this line, I'm getting the output A0, right? So this is a bus line for the 0th bit, right? In the same scenario, if I want to access, like if I want to get an output of C0, right? If I want C0, so what I need to do, I need to enable this one, the second line, right? So for enabling the second line, what I need to go, I need to give the selection line 1, 0. If 1, 0 will be there, then this second line will be on, right? And rest all will become 0, right? This becomes 0, right? And this become 1. So I'm getting this C0 as my output, right? So I hope you understood this. Now this is only for the 0th line, right? This is like bus line for beat 0, right? So if you want to have this entire word, right, of 4-bit, right, 0, 1, 2, 4. So this entire structure, you should have entire circuit, you need 4 times, right? And selection line can be combined with the common one. So if you select 0, 0, so from the all circuits, you select the 0, that is A0, A1, B1, A1, A2, A3, right? Because on the 0th line, we'll have this A, right? And then if you select 1, 0, then C0, C1, C2, C3 will be selected, right? And this output, this is the output, like this is not the actual output. You can say this 0, 1, 2, 3, right? So that means this 0th line along with this, so you are getting the output that is over here. That's A0. Here you are getting B0. Here you are getting C0. And here you are getting D0, right? So similar way, you required 4 circuits like this, right? And this 4 circuits for 4-bit. If I have a 8-bit, then I required 8 such circuit, right? So it's a quite easy implementation. I hope you understood it, right? So this is common bus system for a data transfer. Bus system why we required for the data transfer, right? So this is a common bus system for the data transfer using 3-state buffers, right? So I hope you understood it. Thank you very much.